Hi everyone, and welcome back to another episode of Dr. Card Explains, your YouTube channel where we go through GCSE science content quickly and easily. A big thank you to everyone who has been supporting the channel on YouTube, TikTok and Instagram, especially on TikTok where I am reaching tens of thousands of followers. I really appreciate it. Please do keep following me, keep subscribing, keep telling everyone about the channel, and let's grow this and help as many people as possible. So today we're going to be going over equilibrium. Grab a pen, grab a paper, and let's go ahead and jump in. Okay, so what is a reversible reaction? So a normal reaction would be something like this: A plus B. I'm just going to use some generic equations here. Arrow C plus D. And so normally you have your reactants and you make your products. That's the end of it. But in a reversible reaction, you have A plus B, and then you use this symbol here, which means reversible reaction, and that makes C plus D again. And what this means is that the products can actually go backwards and make the original reactants. Okay, so what is an equilibrium then? So in an equilibrium, the forward and reverse reaction occur at the same rate in a closed system. Now you need to know what a closed system is, and that's just a system where nothing can enter or leave, or nothing can escape from the reaction. And it's really important to remember this word here, that they are occurring at the same rate in a closed system. That means that when you are making the products, you're making the reactants at the same time. Okay, so how can you change an equilibrium? There are three ways you can change an equilibrium. That's by changing the temperature, changing the concentration, and changing the pressure. Now I've also added here catalyst and surface area. Now these 5 things here are able to change the rate of a reaction, but it's only these 3 that can change the equilibrium. Okay, and so it's really important not to get these 2 things muddled up. Rate is how fast you can make it. Equilibrium, by pushing it either to the left or the right, and we'll do some examples in a second, changes the yield of the reaction, so how much you actually make. Okay, so let's go through some examples then. What does increasing the temperature do? And so let's go for an example that the forward reaction is exothermic. Okay, so the forward reaction is exothermic. And so first of all, what I would do is I would write exo at the top here because that's going in that direction, and I would write endo in that direction. Okay, and that means because it's a reversible reaction, if it's exo in one, it must be endo in the other. Okay, so therefore, what's going to happen? If we increase the temperature, it's going to favour the endothermic side. And so what we would say is the yield of A and B, or the amount, would increase. Always start off by just saying what's going to happen to the reaction. Now that could be saying what the concentration increases or decreases. It could be saying that there's a change in color. It could be saying that there is a change in some kind of appearance, but you state what's happening. So in this instance, we're going to say the yield of A and B would increase, and that's because increasing temperature favors the endothermic reaction, and so therefore it pushes equilibrium to the left to counter the change. Now this is all based on something called Le Chatelier's principle. Okay, and essentially it just means whatever change you do to the system will try and counteract that change. And so we have increased the temperature, it wants to decrease it, it favours the endothermic side of the reaction, pushes the equilibrium to the left, and therefore the yield of A and B would increase, and the yield of C and D would decrease. Okay, let's have a look at another example. So what does increasing the concentration of products do? Okay, so obviously we've got our reactants there and we've got our products there. Now, a common mistake here is people start talking about the endo and exothermic side of the reaction. That's only to do with temperature. So what we're going to do then, we're going to look at our reactants here and our products on this side, and it's telling us in the reaction we are increasing the amount of products. So what does Le Chatelier's principle tell us that's going to happen? We're going to counteract that change. And so the yield of A and B would increase, and that's because we've increased the amount of C and D. equilibrium would shift to the left to reduce the concentration of C and D and counter the change. Now, this could easily happen the other way around. If we increase the concentration of A and B, what would happen? The equilibrium would shift to the right, increase the concentration of C and D to decrease A and B to counteract the change. So you can do it either way. I'm just trying to give you several different examples here of how we can change the equilibrium. Okay, what does increasing the pressure do? So here then, I'm going to start with the reasoning first of all. Increasing pressure favours the side with least molecules. I'm going to say molecules slash moles because I've seen both on the mark scheme. Moles slash molecules. Now this is only to do with gases, I should mention. So really I should put little g's here just to show that they're gases. That is an important point actually. So this is normally for gases. And so therefore what's going to happen? So increasing the pressure favours the side with the least number of molecules. And so here I've got 1, 2 molecules, so that's 3 on that side, and I've got 1, 2 molecules, that's 2 on that side. So increasing the pressure favours the side with the least number of molecules, therefore equilibrium is going to shift right. So C and D would increase. What's going to happen? Equilibrium shifts right to counter the change. And again, could happen the other way around. What would happen if you decrease the pressure? If you decrease the pressure, it would favour the side with the most moles, and therefore the equilibrium would shift that way. And so if you just simply state, first of all, what's going to happen, so i.e. the yield changes, the colour changes, the reason, so if it's temperature, concentration or pressure, and then you just state which way the equilibrium is going to shift in order to counteract the change. Okay, I really hope that's helped people out. Do please look at my other videos for more help. Thank you very much for watching. Please tune in next time for another episode of Dr. Carl Explains.